Hi, everyone, and welcome to lesson 1 of Unit 4. And Unit 4 is called Solutions. And really, this is, one category of matter that we've mentioned in the past. And we're going to kind of focus in on this, where it's the idea is that a solute is being dissolved in a solvent to create this solution. But let's start by taking a step back. And this was a chart that you guys have seen in grade 9, probably in grade 10, and we actually reviewed it in the first couple of lessons of grade 11. And that is the classification of matter. And essentially, we define all matter as being one of two main types. So if we say matter, matter can be either a pure substance, or it can be a mixture. Okay, and within the pure substance, we subclassified matter, or we had two categories. The two categories were, we had elements, pure elements, and compounds. Pure elements and compounds. Okay. And then within mixture, we had two types of mixture. We had what was called a homogeneous mixture, and we had a heterogeneous mixture. Okay. And the main difference between the homogeneous and heterogeneous was that with a heterogeneous, you can see the different particles within the substance. So oftentimes they use an example of, cereal, where you can see the milk and the pieces of cereal. And so you can see the different particles. And then homogeneous, the example we use there, where we know there are different particles present, but you can't see them, like apple juice. And the other word for a homogeneous mixture, and here it is, was a solution. Oops, solution. There we go. Okay, and so this is what this unit is. We're down, I just wanted to kind of orient you, excuse me, to where, where we're headed in this unit. Okay, so here we go. This first lesson is a bit of an introduction, so let's do some definitions. So first of all, a solution is a homogeneous mixture. It's a homogeneous mixture. The examples are, salt water is an example. If you dissolve a little bit of salt into the water, you can't see the sodium and chloride ions, but you know they're there because you dissolved it. But it just looks like a glass of water. The other example, obviously, is, there's my picture that I've put, is apple juice. Apple juice looks like one thing. It looks like this brownish, liquid. But we know that there are things present. We know that there's flavorants and sugar and other things in there. So we know that there are different particles in there, and obviously water, lots of water molecules. So we know that there are different particles present. The one thing we'll say about a solution, a couple of points, is that it's uniform. It's uniform throughout. And so it's not like it's darker at one point and lighter at one point. It's very uniform. So that's kind of a point that I would make. And maybe to take that one step further, what I would say, and this is a neat way of thinking about it, is that two samples of a solution would contain the same substances, in the same relative amounts. In the same relative amounts. So if I was to reach in and take a sample of the orange juice from here, and I was to take another sample, I don't know, from the bottom of the container, as I examined the solution, those two samples, so I have one sample here and one sample here, the amount of sugar, the amount of flavorant, the amount of colorant, the amount of, all those things would be the same. You'd have the same relative amounts of everything within those samples. Okay, and that's what makes it a solution. The amount of sugar doesn't vary throughout the container. You're not going to have one section that's going to taste sweet and another section that's not going to be sweet. Okay, one other quick comment here is that you have something called variable composition. Now, a lot of you may say, well, that sounds like you're just contradicting what you just said, Mr. Webster, that variable composition. But what that means is that what variable composition means that there are different ratios of solute to solvent are possible. So maybe to go back to the apple juice example, you can have, like, obviously there's a ratio of sugar to water in that Allen's apple juice. Well, you could have a different ratio. You could put a different amount of sugar in, and so the variable composition means that you don't always have to have like a 1 to 100 ratio. It can vary. And so there's different ratios possible. And I showed it here with this picture. Obviously, let's say that I put a solid in that turned it yellow, maybe iodine. So I added iodine to this container, but clearly there's a different amount of iodine in these different samples. Each of these have a variable composition. Now, a lot of you might start using the term they look more dilute, and that's going to be a big term that we're going to use in this unit, the idea of that you can dilute something. But sure enough, really what it means is that you can have a variable amount in the different containers. Okay. A few other definitions here. I'll just move this one up. A few other definitions. So the solute we will define as the substance. It's the substance dissolved in the solvent. Okay. And the term solvent is any substance that has other substances dissolved in it. It has other substances dissolved in it. And I think the one that we're most familiar with is water. Obviously water, and water is actually, it's been given the term the universal solvent. So you'll often hear water referred to as the universal solvent. It's the one that most other things are dissolved into. I will say that what is the solute and what is the solvent is not always crystal clear, and you'll see what I mean in a little bit. Okay. Here we go. Actually, I'm going to add one more thing to the bottom of this note, just to kind of I've shown a picture here of a solute and a solvent. first of all. So here it is. There's a good example. The solute in this case is this blue crystal. The solvent is water. And when you put them together, you'll put them together and they'll form a solution. Okay. Well, just the one other comment I'll make. When a solute dissolves in a solvent, no chemical reaction occurs. No chemical reaction occurs. Okay? Basically, and by extension, it means that you can separate them by physical means. And that usually means boiling them. I could boil, in this case, I could boil the water and I'd get my crystals back. So in this, if I was to take this solution, this blue solution, and light a Bunsen burner underneath it and boil the water away, eventually I could get my crystals back. And so that's one important thing about a solution. Okay. So, types of solutions. Well, I think a lot of us only think about solids into solvents, like salt into water or sugar into water. And so you got to be careful, though, because there's a lot of other ones. And so let's do the obvious one, though, first of all, the one I just mentioned. So here we go. The first one would be the solute would be a solid, and the solvent would be a liquid. Okay, and a good example of that is salt water. Okay, so that's kind of the typical one. It's the one that most students think of. All right, well, what are some other ones? Well, you could also, the solute could be another liquid. So you could dissolve a liquid into a liquid. And, some of you may say, well, that's just mixing them, but not all liquids will mix. You could have oil and water, in which case, they don't mix. You don't have a solution there. Whereas you could get two liquids that mix really well, and so that it all looks like one. And a good example of this is alcohol in water. So you have two liquids, and you can mix them together, and you wouldn't be able to see them. And obviously, my example here is beer. Beer has 5%. Most beers, anyway, are 5% alcohol. Okay, so I didn't spell that right. Let me fix that. 5% alcohol. Okay, so the alcohol is clearly the solute, and the liquid, the water, is the solvent in that case. Okay, so you can have liquids and liquids. All right, what else could we have? Well, we could have a gas dissolved in a gas. So a solute, a gas dissolved in a gas. And a really good example of this is air. When you air, you don't see that there are different particles, but technically we know that there's oxygen in air, thankfully. There's nitrogen in air. There's carbon dioxide and water, etc. Okay, so the question therefore would be, well, which is the solute and which is the solvent? Like, you may say to me, I get that there, but what would you consider? Well, usually it's whatever's there in the greatest proportion is called the solvent. So I suppose in terms of our atmosphere, we would call the nitrogen the solvent, and because it's about 70%, and then all the other particles would be the solutes, so the oxygen and the and the water vapor and everything else. Okay. Okay. How about the gas? We could also have a gas dissolved into a liquid. a gas dissolved into a liquid. And the example I gave here was Coke, Coca-Cola, or any pop, because really you've got CO2 is the gas dissolved in water. And I showed you here some bubbles. Obviously, when you open the Coke or a pop that's been under pressure, it releases some of the CO2, and so you can see them bubbling. But thankfully, if you drink it fairly quickly, some of the CO2 will remain in the solution, and those kind of give you that feeling on your tongue that is a lot of people like. That's the bubbly feeling. Okay, and finally here, we could have a solid dissolved in a solid. Oh, okay, well that's another solution. And the really good example of this one is are the various alloys that we get. For example, the example I've given here is brass, and brass is a combination of zinc and copper. So it's zinc and copper. Now, when you look at a brass, in this case it's a brass bell, you can't see the zinc and the copper, but you know that alloy was made as a combination of those two, and it turns into this brass. So you could have a solid in a solid. The other term I want to put on this page is, and we've seen this before, is if you ever see the term aqueous solution, and we use the letters AQ to represent it, that's a solution. It's a solution where water is the solvent. Water is the solvent. So if you ever hear that something is an aqueous solution, you know that it's been dissolved in water. Okay, some other definitions. First of all, we got miscible, the term miscible, and basically it's liquids. It's liquids that can be combined. In any proportion. In any proportion. Okay? And what that means is that you could take any combination of the two liquids and combine them, and they would mix. A good example of this is ethanol, which is one type of alcohol, ethanol. You'll learn a lot more about the different types of alcohol next year in grade 12, but ethanol in water. So, ethanol is actually the alcohol that is in alcohols that you drink. And so sure enough, beer is 5%, wine is, maybe from 10 to 14%. Harder liquors can be, upwards of 20 to 30. And then there's, so basically what it's saying is that it doesn't matter what proportion, it will always mix. So in other words, something that is miscible means that you'll never see these two layers form like you do with oil and water. So miscible are liquids that can combine in any proportion. You can have 95% ethanol and 5% water, or 50-50, it doesn't matter, they'll always mix. Immiscible are liquids that don't dissolve in one another. That don't dissolve in one or more proportion. So obviously, oil and water are a good example of that, but even some, it doesn't have to be like that. Oil and water won't mix in any proportion, but notice that it just says one or more. So there are some alcohols, like the larger alcohols, like decanol or even octanol, that at some level won't mix with water. So there's an immiscible proportion for some of them. Okay, the term solubility. Okay, so solubility is a measure. It's a measure of the amount of solute that dissolves in a given quantity. Oops. In a given. Oops. It's the amount, a measure of the amount of solute that dissolves in a given quantity of solvent. Okay. At a certain temperature. At a certain temperature. So it's a measure of the degree to which a solute will dissolve. And it has to be based on a certain temperature, because the higher the temperature, typically the more that will dissolve if it's a solid into a liquid. Now, that's not always the case. When you're talking about gases, it actually changes, but it's the amount of the solute that can go into a solvent, and it's usually given to you in grams per milliliter. But it could also be given to you in moles per milliliter is an indication of the solubility. Okay, just a couple of other quick comments here. Something that is, so the term of soluble versus insoluble. Basically, anything is considered a soluble if its solubility is greater than 1 gram per 100 milliliters. Okay, and something is considered insoluble if its solubility is less than 1 gram per 100 milliliters. So just remember that something that is called insoluble doesn't necessarily mean that none of it will dissolve. Maybe a tiny portion of it will dissolve, but it's still considered to be, because so little of it will, it's considered to be insoluble. And so in order to be rated as soluble, it has to be greater than 1 gram per 100 milliliters. Okay, so that's the kind of the dividing point. Some of you may say, well, wait a second, I know that when I put it in there that I could see that a tiny bit of it dissolved. It can still be considered insoluble, so just be aware of that. Okay, that's an important concept. Okay, we've got these 3 terms that are often used in this unit or discussed, and that's saturated versus unsaturated versus supersaturated. Okay, so I just wanted to distinguish these. So something that is saturated, if you're saturated, what that means, it occurs when no more solute will dissolve, and excess solute is present. Okay. I want to put a little star here that it is temperature dependent. So if you were to change the temperature, the saturation would change. Temperature dependent. So in other words, typically, like let's say you were at room temperature, and here I'm just going to show you a little example. So here it is. We're at room temperature, and I've got a glass of water, and here it is. Oops, I meant to change it, whatever. So I have a glass of water, and I start, so here, I'll just write here that I've got water, and I start spooning. I put a spoonful of, let's say, let's use sugar. So I put a spoonful of sugar in. So I put sugar in, and I stir it, and the sugar dissolves. So I know I'm not saturated because it's all dissolved. But then I put another spoonful of sugar in, and I keep adding more and more spoonfuls, more. And eventually what happens is I get to what's called the saturation point. And at the saturation point, my next spoonful of sugar that goes in doesn't dissolve. In fact, what happens is you start seeing that you start building up this little pile of sugar at the bottom. Even though I'm stirring it, if I stir and stir and stir and stir and then stop stirring, eventually you see some sugar settling at the bottom. It means that I've reached the saturation point. It means that no more sugar will dissolve. And so that's what saturated means. But you don't know you're there until you at least see a little bit of sugar that's floating around. I can't know that I'm at the saturation point until I see that little bit of sugar floating around. Okay? And if I change the temperature, it could change the saturation point. In other words, if I heat the water up, I could probably dissolve more sugar. So it is temperature dependent. Okay. The term unsaturated basically means, as it implies, it's not yet saturated. Not yet saturated. It's not yet saturated. Therefore, more solute can still dissolve. More solute can still dissolve. Okay, so that's pretty clear. And then finally, something that is super saturated. Well, what that is that when you take a saturated solution, like the one we were discussing earlier, so you've added sugar to it, and you've added more and more and more until finally it won't take any more. When you take a saturated solution, you can temporarily, let me go backwards for a second here. When you take a saturated solution and cool it, you can temporarily, oh my goodness, temporarily, all right, I'm struggling here, you guys. Let's see what happens here. You can temporarily have more solute in solution than is typical for that temperature. So you can imagine you've got this saturated solution at room temperature, and all of a sudden I take it and I stick it in the freezer. Well, as the water cools, the solute won't come out of solution immediately. And so at that new temperature, it's technically super saturated is what they call it. Okay, so it happens temporarily, and then eventually the solute will come out and it'll go back to its saturation point. Okay, there you go. So that's kind of an introduction to solutions. I'd like you to work on these. These are sectional review questions. They're just kind of asking you to look at and consider some different examples. So please, there's a few definitions in here that you may have to look up, but for the most part, it's kind of just asking you to consider things from what we've studied in this note. Okay, so good luck with that and take care, you guys.